Hey everyone, welcome back. In this particular tutorial, we are going to learn about operator precedence in Python. And if you Google about operator precedence, you will see a very big table with so many operators. But we are not going to memorize that whole table. That's not what we are going to do. Rather, what we will try to do is we'll try to understand the importance of operator precedence and also how it is used to evaluate the expressions. And then we'll see the operator precedence of arithmetic operators in Python. Operator precedence basically helps to determine how operands are grouped in an expression. Let's see why this is important. Let's take this example, this expression 3 plus 4 star 5. Now, when we want to evaluate this expression, there is an ambiguity here, right? So should we group 3 plus 4 together and then multiply with 5? Or should you group 4 star 5 together and do 3 plus 4 star 5? As you can see here, in this case, you will get 7 star 5, which is 35. Here you will get 3 plus 20, which will be 23. So based on how grouping is done, your final result will vary. When we say grouping, it is just like putting a parenthesis this way. That's what we commonly do when we solve problems in mathematics also, right? So to resolve this ambiguity, Python uses something called operator precedence. If you see these operators plus and star, these are arithmetic operators, right? So first let's try to understand the precedence of arithmetic operators. Arithmetic operators follow PEMDAS rule for operator precedence. You might have studied about this PEMDAS rule, or some people also call that as BODMAS rule, while evaluating mathematical expressions, right? This PEMDAS is basically an acronym to remember the precedence order of different operators. So if you see this operator precedence table, and if you go from left to right in this PEMDAS, the first operator is parenthesis. It has the highest precedence. Next is E, which is nothing but exponent, which is double star operator. Next we have MD. As you can see, both have same color. There is a reason for it because multiplication and division related operators will have same precedence. So we have star, which is for multiplication, and then we have floating point division, floor division, and modulus. All these are related to division only, right? So all these operators, which are multiplication and division related operators, have same precedence. Next, we have AS, which is nothing but addition subtraction. Even these two will have same precedence. So parenthesis has the highest precedence, then exponent, then multiplication and division related operators, then you have addition subtraction. For now, ignore this last column called associativity. We'll come back to it later. So this is the operator precedence of arithmetic operators. Now if we go back to our example, as we can see here, we have 3 plus 4 star 5. We have plus operator and star operator. If you see this table, so here we have star, here you have addition and subtraction. So star has greater precedence than plus. So that's why 4 star 5 is grouped first. So if you take this 3 plus 4 star 5, first it will group this 4 star 5. Now once 4 star 5 is grouped, then this plus is used for grouping. So it will be 3 plus 4 star 5. As we don't have anything else, it's okay even if we don't put this outer parenthesis. So the final value will be 3 plus 4 star 5, which is 20, which will be 3 plus 20, 23. But now what if we want the expression to be evaluated as 3 plus 4 star 5 instead of 3 plus 4 star 5? In that case, we need to explicitly add parenthesis accordingly. So if you put this parenthesis around 3 plus 4, we know that parenthesis has the highest precedence, right? So when you put this parenthesis around 3 plus 4, you are explicitly saying to Python to follow the same grouping. So if you do this, now the value will be 3 plus 4 star 5, which will be 7 star 5, 35. Now let's verify this in the code. So I opened my PyCharm. So here inside operators folder, I'll create a new Python file. operator underscore precedence. All right. So here let's print 3 plus 4 star 5. So this is how it will be grouped, right? This particular expression. Now let's try to run this program. Right click, run operator precedence. As you can see, the value is 23. Now, if you want this to be evaluated as 3 plus 4 star 5, then you have to use parentheses explicitly this way. Now, if you try to run this program, you can see now it is 35 because 3 plus 4 is 7. It will be 7 star 5, 35. Now, what if we have multiple operators with same precedence in an expression? Then how to resolve it? A small correction here. It should be operators, not operands here. So let's see what happens when we have multiple operators with same precedence. If you see this example, here we have 20 star 6 modulus 5. Here you have star and modulus operators. As you can see in the table, star and modulus, they have the same precedence, right? So again, there is an ambiguity here. If we group this as 20 star 6 modulus 5, it will be 120 modulus 5. Modulus is nothing but remainder, right? So it will be 0. But if we group this as 20 star 6 modulus 5, this 6 modulus 5 evaluates to 1. It will be 20 star 120. So again, there is an ambiguity here. In such cases where there are multiple operators with same precedence, Python uses associativity for grouping. If you see in this table, we have this column associativity. If you see here for parentheses, I did not put any associativity because when you have parentheses, it's explicitly mentioning how to group, right? So there is no point of having associativity because things are already grouped. Now, if you see the other operators, apart from exponent operator, which has associativity from right to left, all other operators have left to right associativity. So what do we mean by left to right associativity? It means that in an expression, if we have multiple operators with same precedence, Python will choose the operator which is on the left first for grouping. Then it will choose the next operator in the direction of left to right. When I say left to right, I don't mean left to right in this list. What I mean is inside an expression, whatever operator occurs on the left, that will be chosen first. So in this particular expression, we have star and modulus. Both have same precedence, right? We have seen that star and all division operators have same precedence and they are left to right associative. So grouping should happen from left to right. Just to clarify again, when I say left to right, I don't mean the left to right order in this list. What I mean is inside this expression, whatever operator happens on the left, that should be chosen first. Here we have star operator on the left and modulus on the right. So Python will choose star operator first for grouping. So it will group 20 star 6 first. Then it will group based on modulus operator. So our final expression will be 20 star 6 modulus 5. If we evaluate this, 20 star 6 is 120. Modulus is nothing but remainder. 120 modulus 5 will give us 0. So let's verify this example, 20 star 6 modulus 5. Now let's run this program and you can see the output is 0. Now let's see some more examples. So here first example we have 2 plus 3 plus 4 star 5 modulus 6. Here we have plus operator, star and modulus. And we know that star and modulus have higher precedence than plus. And both these have same precedence with associativity from left to right. So here star and modulus have higher precedence than plus. So we should group these first. And also they have left to right associativity, right? Which means that we should group them from left to right order. So you will be grouping 4 star 5 first, then you will be grouping based on modulus operator. Then the expression becomes 2 plus 3 plus 4 star 5 modulus 6. This is already grouped. Now we have plus and plus operators. As they are same operators, they will obviously have same precedence. And we know that plus also has left to right associativity. So you first group this 2 plus 3 first. So it will become 2 plus 3 plus the rest of it. Now this plus is grouped. So it will become, 2 plus 3 plus 4 star 5 modulus 6. Now if you try to evaluate this expression, 2 plus 3 evaluates to 5 plus 4 star 5 evaluates to 20 modulus 6. 20 modulus 6, what is the value? What is the remainder? It will be 2, right? So the value will be 5 plus 2, 7. So I have added that example here. As we are going to print a lot of things, I've just put a, print message example 1, and I also put a comment for clarity. All right, so this is the expression we discussed about, right? Let's see the output. Let me run it. So you see the output is 7. Now, one thing I would like to mention is that when you want to find the value of this expression, let's say in an exam or anywhere else, so you don't need to do this grouping completely. You can stop at a stage where there is no more confusion for you. In this particular expression, once you group star and modulus operators, you will get something like 2 plus 3 plus, the rest of it, which is grouped. We can stop grouping at this stage when we want to evaluate and find the value, because this is of the form a plus b plus, and this is one operand c, right? So when you take a plus b plus c, the grouping doesn't matter. If you group it as a plus b and then add c, or if you add a to b plus c, both of them will give you the same answer. The grouping doesn't matter. So at this point, you can stop grouping. And I'm explaining this step by step just to give you a visual understanding of what happens when Python evaluates the expression. Once you are comfortable with the concept, you don't even need to write all these steps. You can simply do it in your brain, just like how we evaluate simple math expressions. Let's see the next example now. We have 8 modulus 3 star 2 star 4. So modulus and star, they have same precedence, and associativity is from left to right. So first it will group 8 modulus 3 in this way. Then it will group based on star operators from left to right. So the next grouping happens this way. And then this final star, which is on the right side, will be grouped. But you can stop at this point because this is just like A star B star C, right? So A star B star C is equal to A star B star C. So grouping doesn't matter at this point. So you can stop here and evaluate the value. So the value will be 8 modulus 3, which is nothing but remainder. It will be 2 star 2 star 4. The final value will be 16. I have added this example here. So this is how grouping happens, right? So let's evaluate this. Let's run this. You can see value is 16. Next we have 2 double star 3 double star 2. So this double star is exponentiation operator, right? We have seen that in case of addition or multiplication, the grouping doesn't matter. If you group A star B and then do star C, or if you group B star C and do A star B star C, both will be same. But when it comes to exponentiation, if you see, so if we group this from left to right, it will be 2 double star 3. So this will be grouped, and then this star is used for grouping. We can ignore the outer brackets. Now if you evaluate this, it will be 2 power 3, which is 8, and then power 2. 8 power 2 is 64. Now if we group this from right to left, which means if we group this right side exponentiation operator first, it will be 2 double star 3 double star 2, right? So 3 double star 2 is nothing but 3 power 2, which is 9. So now this is 2 power 9, which gives us 512. So as you can see here, based on the order of grouping, we are getting different answers. So in this case, associativity is important. Now we know that for exponentiation, associativity is right to left, which means the right side exponentiation operator will be grouped first, and then this left side operator will be grouped, right? So if we evaluate this expression, this will be 2 double star 3 double star 2, which is what we have calculated here, right? We'll get 512. Now let's verify this example. So I have added that example here. Let me run the program and we can see that we got 512. Now that we understood how operator precedence is used for grouping in the expressions, one important point we need to remember is that when we write programs, it's recommended to use parentheses to avoid any confusion or ambiguity. For example, let's say we have an expression like a plus b star c. Now, if someone doesn't remember the operator precedence, so this can be confusing, right? So it has very less readability and it can be confusing as well. So instead, let's say if you want the expression to be evaluated as a plus b star c, then you can use parentheses this way. Or else if we want the expression to be evaluated as a plus b star c, we can use parentheses this way. Now, when we write expressions this way, so it is very clear and easy for others to read and understand your program. Now, if we don't use parentheses in this expression, how will this expression be grouped? Star has higher precedence than plus, right? So B star C will be grouped. So it will be A plus B star C. Now, even if you want the expression to be evaluated as A plus B star C, still it is better to use parentheses and not rely on operator precedence. Remember that when you write program, always keep in mind the other person might not remember the operator precedence. So if you feel there is any scope of confusion or ambiguity, always use parentheses. And this is the reason why it doesn't make much sense to, remember the operator precedence of all the operators. Because when we write programs, we generally use parentheses to clearly specify the grouping. If you remember the operator precedence of arithmetic operators, that is good enough. And one more thing about operator precedence is that operator precedence and associativity only determines how operands are grouped in the expression and not the order of evaluation. Because Python evaluates expressions always from left to right. We will discuss more about this in the next video. We'll also see a demonstration to understand the order of evaluation of expressions. I'll see you in the next video.